Hi guys, today let's discuss the LeetCode question 17, letter combinations of a phone number. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. In the below image, a mapping of digits to letters is provided. So 2 represents ABC and 3 represents DEF and so on, and till W represents WXYZ. Now we are going to find all the combinations that are going to be formed by the given digits. Let's go to the examples below. In the example 1, the digits is 2, 3, and the combinations that can be formed are AD, AE, AF, and BD, BE, BF, and CD, CE, CF. Let's go to the example 2. In the example 2, the digits is an empty string. In this case, we are going to output an empty list. So this is going to be a corner case. Let's go to the example 3. When the digits is 2, the output is going to be ABC. So this is going to be our base case for our recursion. I hope it is very clear from this question description. Let's go into the explanation part of it. For the purpose of explanation, let's consider the digits to be 2, 3, 4. And let's use this 2, 3, 4 as an example to understand the recursion tree for this question. So the first level is going to be ABC because ABC represents the digit 2. Then the next level of this recursion tree is going to be DEF because this DE and DEF represents the digit 3. And the next level is going to be GHI. The reason we have this GHI in the form of a list is because we are going to output in the same format, and this is going to be our base case. Once we have reached this bottom of this recursion tree, the control actually flows back to the previous step. So let's go to the step 2 of the recursion tree and see the output of the list. For this DEF, the output is going to be something like this. So we are going to append D to all the below base case list, which is GH and I. So we are going to get DG, DH, DI, and followed by EG, EH, EI, and FG, FH, and FI. Once this level is completed, the control actually flows back to the previous level of the recursion tree. So once the control actually flows back to the previous step, for A, the output is going to look like this. We are going to get ADG, ADH, ADI, AEG. The way we get this is we are going to append A to the below obtained list. Then we are going to get this list. Same thing happens even for B and C. So we are going to add all these cases, and finally we are going to get a list of 27 strings. So I hope it is clear from this explanation. Let's quickly code this up. Let's start by solving the corner cases first. If not of digits, then we are going to return an empty list. Then we are going to create a helper function. And we are going to pass the parameter to that as index. If index equal to length of digits minus 1, this is going to be my base case. So in my base case, I am going to return a list of phone dict of digits minus 1. So for the last character in the digits, I am going to output as a list. In the else case, I am going to loop through each character in the digits, and I am going to take the corresponding phone dictionary string from it. So for character in phone dict of digits of index. So with this I am going to get the corresponding string for the particular digits provided from the index. We are going to store the entire result in a result list. Then we are going to store a partial result as well from the recursive calls. So we are going to name it as partial result. So we are going to call the helper function on index plus 1. Then we are going to loop through this partial result list for partial in partial underscore result. Then we are going to add this partial result to the particular character that we are taking from the digits of index. So it is going to be character plus partial. And finally we are going to return the result. So we have completed coding our helper function. So finally we are going to call this our helper function. So we are going to call the helper function on index 0. I hope we are done. Let's quickly run the code. Yeah, it is accepted. Let's quickly submit as well. Yeah, it is submitted. Hope you liked the explanation. For more such videos, please subscribe to my channel. Thank you.